Good evening everyone, Lakshmi Narayanan here. So today we will be seeing a sum on the topic of an object on an inclined plane with some friction on it. So now let me read out the question first. So find the force P inclined at an angle of 32 degree with the plane, making an angle of 25 degree with the horizontal, and the block weighing 125 kilonewton up the inclined plane when the coefficient of friction between the block and the surface is 0.5. So now we have to find the force P with which the object is pulled upwards the inclined plane when the plane is inclined at an angle of 25 degree from the surface. So now let's move on to the solution. So upon resolving the forces, the final diagram will come something like this. So I will just resolve it and show it to you once again. So now let's consider it as the horizontal and an inclined plane. So let us consider the object like this. So they have mentioned that the weight of the object is 125 kilonewton and it's inclined at an angle of 25 degree. So now upon resolving, we will get the same angle 25 degree here. So this will be the normal force which will be acting perpendicular to the surface and the body, and now this will be the vertical component of the mg, that is 125 cos 25 degree. And now as we have seen here, we are given P, so it also has some angle, so there will be both horizontal and the vertical component of even the force with which the object is being pulled upwards. So when we resolve it, we will get P cos 32 in the horizontal direction and P sin 32 in the vertical direction. So now what's remaining? Now we have resolved the 125 kilonewtons vertical component, and still its horizontal component is remaining. So it will be nothing but, so if it is 25, then its opposite direction will be something acting like this. So it will be, if you write it here, 125 sin 25 degree. So now whenever an object is moving in a rigid surface, there will be always a frictional force acting in it in a direction opposite to which the object moves. So we should consider a frictional force Fs here, and also we have already given the coefficient of friction is 0.5 in this case. So now let's move on to the calculation part. So firstly we have to solve both the cases, that is the forces in the horizontal direction as well as in the vertical direction. So we will get two equations. So upon solving the two equations, we will get the required force with which the object is being pulled upward the inclined plane. So now let's take the horizontal case. So when we take the horizontal forces acting on the object, so we will get P cos 32 acting in the rightward direction and 125 sin 25 and the frictional force. So you will get an equation like this, as P cos 32 is acting in this direction and these both forces are acting opposite to it. So upon equating it, we will get it to 0. So then upon solving, P cos 32 will keep it as such, and frictional force. So frictional force, we know the formula, frictional force is equal to the coefficient of friction into the normal force acting upon it. So we will write it coefficient of friction into the normal plus. So upon solving sin 25 into 125 degree, we will get the answer is 52.827. So we already know from the question that the coefficient of friction between the block and the surface is 0.5. So I will substitute it here. So we will get the equation of this kind, like P cos 32 degrees equal to 0.5 Newton plus 52.827. So our first question is over, which we have solved by taking the horizontal forces. So now we will form another equation by considering the vertical forces acting on the object. So while considering like that, we will what we will get? We will get first normal force plus P sin 32 is equal to the opposite force, which is the force which is opposite to it in the downward direction, that is 125 cos 25 degree, which is nothing but the vertical component of the weight. So we will get that equal to 0. So upon solving the similar case as before, 125 cos 25 equals to 113.28. So upon rearranging, we will get an equation like this. So now what we will do is, we will take n from that equation, from the second equation, and keep P aside. So now upon substituting this in the first equation, that is nothing but P cos 32 is equal to 0.5 n plus 52.827. So upon substituting in this and solving, you will get the final answer of P, that is the force with which the object is being pulled. So we will get it as something like 98.61 kilonewton. And then upon substituting in the same equation, we will also get the normal force, which is not asked in the question, but it's well and good if you find it. So this is how the sum is being carried away, and then we are finding the answer of it. I hope everyone got it, and have a good day.